Okay, we're recording. This is going to be a recap of homework number 20, which is the pages 5 through 6 of the 4.3 notes, the Google form that goes with it, as well as the textbook problems on section 4.3. So first off, I picked up the video over here, and we talked about derivative inverse functions in general, and how we notice that they're reciprocals of each other. When I say they, I mean the original function as well as the inverse. But it's a little bit confusing. So before we recap all this stuff, let me do a quick little demo here with you guys that might help. You guys can just sit back and relax. If you want to take notes, you can. Totally up to you. So I'm sharing a whiteboard right now. And let's say I had this as a function. Let's say like y equals x squared plus 1. In fact, let's say it's f of x equals x squared plus 1. Okay, that's easy enough. Now, when I do the inverse, you switch x and y. And you isolate y. You have to square root. And it will be plus or minus. Okay, so our inverse is this. So I have my original and I have my inverse. Now let's take the derivative of the inverse. Sorry, the derivative of the original. It's just going to be 2x, right? Let me take derivative of the inverse. And maybe I'll just focus on the positive square root, just to simplify things. And the way you write the derivative of the inverse, it's kind of weird, but you usually put a parentheses around that and then a little accent mark and then the x. Some people do this also. I used to do it this way. Actually, I still kind of do. But the textbook and the notes do it more like this. So just so you know, it just means you're doing the derivative of the inverse, you know, not a big deal. Pretty, that should be pretty straightforward. Anyway, if I do that derivative, that should be using a bit of a chain rule. So 1/2 raised to x minus 1, and then that's raised to a negative half. So if you were to clean that up, it'd be 1/2 root x minus 1. Okay, now let's do some evaluating. Let's go to green here, kind of festive. So f of 1, let's say I find f of 1. I just feel like finding f of 1. What is that? That's going to be 2. Now on the inverse, what if I plug 2 into the inverse? I'm doing root 2 minus 1, which is 1. So it kind of makes sense that for f, let me do a little summary table here in black. We have 1, 2. So the inverse, we have 2, 1. Sorry, inverse, that's what I meant to write, right? 2, 1. Totally makes sense, right? Now, what if I do this, f prime 1? That's going to be 2, right? So f prime of 1 is 2 here. Well, what about plugging in 2 into the derivative of the inverse? So if I evaluate the derivative of the inverse at 2 for x, I get 1/2 root 2 minus 1, or 1/2 times 1, or 1/2. So the derivative of the inverse at 2 equal 1/2. And notice how these are reciprocals of each other. That's 2 and that's 1/2. And that's the expectation, is that when you have the derivative of an inverse function in general, it's that derivative is going to be the reciprocal of the derivative of the original, but the things that you do have to swap the inputs to. And that's why you see this as a y coordinate and that as an x coordinate. It's also a little confusing, but you do have to swap those inputs because you have inverses, right? You always swap inputs and outputs for inverses. This, I think, schematic kind of helps a little bit. And I'll actually model this for you guys in just a little bit so you guys get the hang of it. But in example 4, f and f inverse. So you're told that f5 equals -11, so 5 comma -11 is a point on the original. So what's going to be a point on the inverse? Them switched, -11 comma 5. We know this. That's how inverses work. Therefore, f prime of 5 equals the reciprocal of the derivative of the inverse evaluated at -11. That's the whole point of this lesson. Well, f prime 5, well, actually, we're not giving f prime 5. You're given the derivative of the inverse evaluated at -11, which is -3. Therefore, f prime 5 is -1/3. It's a reciprocal. Now, demo I just gave you guys with x squared plus 1. Prove that. Now, there is some theoretical stuff. And you have to be very conscientious that when you're doing the derivative of the inverse, you want to guarantee that your original function is differentiable everywhere, and that your original function also passes the horizontal line test. I didn't draw that really as well as I could have. So for example, this passed the horizontal line test, right? Something like this will not pass the horizontal line test. Why is it a problem if I don't pass the horizontal line test? If I don't pass the horizontal line test, this tells me the graph is coming back down again, then back up. So therefore, I will have a horizontal tangent somewhere. That's a problem because what does a horizontal tangent mean in terms of a derivative? It means you have a derivative of 0. Well, remember, derivative inverses are the reciprocal of the derivative of the original functions. So if you have a slope of 0 or a derivative of 0, and then you try to take the reciprocal of that, that's undefined. And so that's why you have to guarantee that you're a one-to-one function. We mentioned in the video. One-to-one meaning for every x there's one y, and for every y there's only one x. So it passes both vertical and horizontal line test. So theoretically, we must guarantee that. And also, you want to make sure your original graph is nice and smooth everywhere, so you don't have any issues like if there's corners, you can't find derivatives and whatnot. So you want to make sure everything's nice and clean. Now let's go to the Google form. First off, good work. Number 5. Yes, wear a mask, stay 6 feet apart. Don't go to public places that have a lot of people. Wash your hands. Fortunately, my second coronavirus test came out negative. I took one on Monday again. I'm feeling much better, so hopefully I'll be back to campus next week. I know you guys are still probably not going to campus, but if you happen to see me on campus, or if I need to give you guys copies and leave in the lockers, anyway, I'm feeling better. So, but be careful out there. Anyway, number 1, yes, they're reciprocals. That's exactly how they're related. They are reciprocal, and ooh, that's good. F prime of x equals 1 over f prime of y. That's exactly it. And actually, another document I should have had opened, I don't know, I didn't open it earlier today, is the cheat sheet. And the cool thing is that we're going to see all these now. You have this right here. We've done these already, and we're going to do all these. So this cheat sheet will be fully complete for us now after today. Anyway, going back to the Google form. So why do we need to make sure the derivative of the original function does not equal 0? Because then you can't take a reciprocal, right? That's a problem. So that's why you have to, pass the vertical horizontal line test to make sure that the derivative inverse will exist. And then this one, if you work this one out, let's try this here. Now here's a problem with this one. Y equals x squared plus x, right? If you want to find the inverse, knock yourself out. It's going to be a totally worthless endeavor because I can't isolate y there. So this is why we need this general rule. I gave you guys y equals x squared plus 1. That's when we could find the inverse up and then take the derivative of both to prove that if I plug one thing into the original and another thing into the inverse, the derivative of the inverse derivative of the original, the reciprocals, right? So unfortunately, I can't find the inverse of this function here, but don't worry. We're valuing this at 6, so f inverse 6 comma. If I plug 6 in that, I get 42. Therefore, I get 42 comma 6 on the inverse, right? That's the whole point of inverses. Now, the derivative I could find of the original, that's easy. That's just 2x plus 1. So f prime of 6 is going to equal the derivative of the inverse evaluated at 42. That's the whole rule that we've been talking about, because the input here now is 42 because it's swapped from the original. Well, f prime of 6 is easy. That's 13. So 13 equals this junk here. So my derivative of my inverse is going to be 1/13. So if you put 1/13, that is correct. 1/13 is the correct answer. We're going to try this again. We're going to look at the homework, lose a few times so you guys finally get it. Okay. Now I'm doing homework review. Sorry, textbook review. Oh, come on. Here we go. Okay, let me give you guys the answers first. And then ask questions. And hold on, I'm just going to pull up the homework images on my other device here so I know what problems I asked you guys here. PDF. Come on, download. There we go. Great. Okay, so number 1, maybe I'll expand this just a bit more. And let me maybe get a highlighter out. That's always a good idea. So I asked number 1, and there's the answer. And I asked number 7, and there's the answer. And number 17 is on another page. So question about 1 or 7. And if you want me to go over those, let me know. No? Okay.
Actually, can you do 7, please?
Yeah, okay. So for 7, ooh, that's a good one. Let me go back to the other document. Okay, so where I have more space. Okay. So you have to do your product rule. So 1 times inverse sine of x plus x times derivative of inverse sine, which is 1 over root 1 minus x squared. And then plus, you got to do a chain rule here. Move the 1/2 to the front. 1 minus x squared raised to -1/2 times -2x times the inside. They did simplify it. So you have that plus x over root 1 minus x squared plus, now you have 1/2 times -2, so it becomes -1 up top, and there's an x there. And you have something raised to -1/2 power, so it's on the bottom, and it's a square root. What happens to those two fractions? They cancel. Leave it just that. So occasionally I will care to simplify. If I pose a multiple choice problem, I will have it simplified, which explains why I signed all these here. In fact, let's jump to those 37 through 40. Then we'll look at the other ones. Okay, here are all the answers for that. Let me go highlight out again. Let me position a little better. There we go. 37, 38, 39, and 40. Answers are E, D, A, and C as in cat, number 40. Okay, any of those you'd like me to do? You can put in the chat or just speak in your microphone.
Could you do either 38 or 39, please?
We'll start 38. I'll do both. How about that? For 38. Okay, what's the derivative inverse tan? 1 over x squared plus 1. Or u squared plus 1. What's your inside? 3x. So you can do that. Oops, sorry. And then chain rule. Times root of 3x, which is 3. So you get 3 over 9x squared plus 1. That's why it's D. Let's look at 39. Okay, for 39, you have derivative inverse secant. Derivative inverse secant's 1 over absolute value of u times the square root of u squared minus 1. So that's the formula. Remember, it's in your cheat sheet. What's your inside? X squared. Times the square root of u squared. So you're squaring x squared, so it's x4 minus 1 times that derivative, which is 2x. Okay. Well, you clean it up. Those cancel. So that's why you get A. So all of this is chain rule and just using the formulas. That's all you're doing. Question in the chat. Have 1 minus u squared under the root. I think, are you referring to 37? The person asked the question.
The identity of first inverse of secant, I thought it was the absolute value of x times the square root of 1 minus x squared.
I made a mistake on that, and I made a mistake, and I corrected myself, but I probably glossed over it. It's the other way around. Yeah, and that's what happens when you don't teach math in 2 weeks. You forget stuff. So it's the other way around. It's x squared minus 1.
Okay.
Yeah, and we can go through that derivation again, but I won't in the interest of time. So okay, let's keep doing. Look at the other problems here. Clear. We also had 17, 22, 24, 27, 29. So let me position that a little bit better. one sec here. Okay, let me work out 17 because I don't want to keep moving back and forth. Plus, I think maybe people might want to see that anyway. For some reason, the textbook does things in slope intercept form. I don't know why, but so 17 again. The formula is this: 1 over depth value times square of u squared minus 1. So my apologies if I didn't give that to you guys correctly the first time around. So when I do 17, I'm going to do 1 over the upside 1 over t times square of 1 over t squared minus 1. But then I got to do the derivative of 1 over t. And then you have to evaluate all that stuff. Now, actually, let me move to page 171 so you can see the answer. Let me clear this other junk here. So the answer 17 is shown right here. So how did it get all this to look like that, right? How do we do that? Okay, well, I'll show you how. Well, first of all, 1 over t is t to the negative 1 power, right? So that's negative 1 times t to the negative 2 power, or negative 1 over t squared. So that's what I'm going to do over here. I'm going to have 1 over t. I'll get rid of the opposite value because things are going to cancel anyway, times square roots. That's going to be 1 over t squared. And minus 1, or I'll say minus t squared over t squared. Then times negative 1 over t squared, because that was my derivative. Well, you would see that, oh, those cancel. You have 1 times negative 1 up top. So now I got myself negative 1 up top. And the 1 over t and t squared cancel. I have a t right here. And I have the square roots of 1 minus t squared divided by the square root of t squared on the bottom, which is just going to be t. And those cancel also, giving you that as an answer. Remember, when you square up fractions, I know I kind of glossed over just a little bit. You have 1 over t squared minus t squared over t squared. So that's 1 minus t squared over t squared. You totally are at liberty of doing those individually. You totally could do that, right? That's totally fair treatment for radicals. And what's square root of t squared? Technically, it's absolute value t, so I probably should have just wrote that, but I'll just write t because I'm lazy. Things are canceling anyway, so I'm not too worried about it. And yeah, that's how I got that there. And then I canceled that with this other t, because remember, when I took the derivative of 1 over t, I had negative 1 over t squared, and that t squared canceled that 1 over t that we have from over here. So it's a lot of canceling that goes on with these problems. Remember, you can always verify your work using the TI 84 calculator. Excuse me. So that's what's happening there. Okay. And going back to the other page. Again, I gave the answers for 22 and 24. They're right here. Again, you just have to use, like for 24, for example, just use the rule, which is 1 over 1 plus x squared. And you're valuing at 2, so you get 1/5 as your slope. That's easy. And then you guys would know that's y minus y1 equals m times x minus x1. So you have 1/5 times x minus 2. And then you have to evaluate the inverse tan of 2 using your calculator. So you plug 2 into the original, get that, and then they decide to put it in slope-intercept. Personally, I want you guys to keep it in point-slope form. Don't move things with slope-intercept. I don't want you guys doing that. The textbook does it. I don't know why. Excuse me. And let me show you the answers. If you have a question about 22, maybe ask me later, because I do need to keep things moving here. 27, 28, 29 are all right here. All the answers. 27, 28, 29. 27 is pretty straightforward. You know derivative tangent secant squared x. Plug in pi over 4, work it out. You get your slope of your tangent line. And then inverse, we already did that for number 22. Sorry, for number 24. Those are the answers there. Your answer might look a little different. That's okay. Maybe if you want to write that down, just check to see if you did it correctly. And then here are the answers for 28, excuse me, and 29. Let me do those quickly because I want to give you guys a little practice of this in just a little bit. So for 28, f of 1, that's easy. Just plug 1 in, you get 1 plus 2 plus 1, 1 plus 2 plus 1 minus 1, that's 3. Easy enough, right? The derivative is easy too. What's f prime of x going to be? 5x4 plus 6x squared plus 1. Plug 1 in, that's easy peasy, 12, right? Now, remember, we have one, so let's make a little table here, f and f inverse. We have 1, 3 as a point, so guess what? We have 3, 1 as a point. So when you evaluate the inverse at x equals 3, it's gonna be 1. You can't find the inverse function itself. You can switch x and y, so you get x equals y to the 5th plus 2y to the 3rd plus y minus 1, but good luck in trying to isolate y there. That's actually mathematically impossible. So just realize that if you have 1, 3 as a point on the original, 3, 1 is a point on the inverse, right? They switch x and y. We know this. So therefore, f prime of x, whatever that is, or f prime 1, is the reciprocal of the derivative of the inverse evaluated at 3. Well, we know f prime 1 is 12, so therefore this is 1/12. That's all we're doing. That's all we're doing there.
For E.
Mhm.
So in the work you're finding f prime of 1, but isn't the question asking for f or inverse of 3
In part A?
in part B?
Yeah,
That's
exactly.
fine.
Yeah, I did. I did find the inverse of 3 is 1.
Okay.
Yeah, why is it 1? Because when I did f of 1, I got 3, right? In part A. If f of 1 equals 3, then by all means, if f of 1 equals 3, then the inverse at 3 has to equal 1. Because that's the whole point of inverse functions. X and Y have to switch.
Okay, got it.
So now this is the calculus part. This part that has been a little tricky, but I'm trying to make sure I'm very consistent and clear about this as best as I can be. It's a hard concept, I will agree. And this is the one thing, this is the crappy thing with the next semester, is that I see you guys for 4 weeks in January. I don't see you guys, well, formally I don't see you guys, but hopefully if you guys want to take advantage of whatever opportunities I give you guys to prep for the AP, this is the one concept when I do AP review in the spring that almost everyone forgets. I mean, and the way we have it set up, you guys are definitely going to forget this. So we have to, review this over and over again, because it's one of those things that doesn't get reinforced, unfortunately. Maybe in January, maybe I might just give you guys inverse function worksheet, so you guys get so sick of it that you, because it's just one of those things that people forget easily. But anyway, now I know I have 1, 3, so I have 3, 1. The value of the derivative at 1 was easy. I found the derivative of my function and plugged 1 in, I got 12. Therefore, if I evaluate the inverse derivative at 3, it's going to be 1/12. Because 3 now becomes the input for the inverse because I swapped it from 1, 3 from the original. Remember, 1, 3 is on the original, 3, 1 is on the inverse. F prime 1 is whatever. It's going to equal the reciprocal of the derivative of the inverse evaluated at whatever x value I see there, which was 3. And that's what we're doing. Let's do this one more time, then I'm going to move on. So first of all, show that f has a differential inverse. All you really need to do for this is make sure it passes horizontal line test and graph that in Desmos. Don't do that by hand. Pass horizontal line test and smooth. Make sure it's a smooth curve. And it will be. Then what you need to do, again, why we're passing horizontal line test? Because you don't want any horizontal tangents. So you want the graph to always keep increasing or to keep decreasing. You don't want any hills. You don't want anything like this, right? Because if you do, then you have a horizontal tangent. Then you have a derivative of 0 somewhere along the way, and therefore you can't do the inverse of the derivative of the inverse, because you can't do the reciprocal of 0.
Mr. Reed?
Yeah.
I have a question about that. I thought on the video notes there was a parabola that ended up working. What about parabolas for that?
On the interval, no. If you do for an interval of all real numbers, no. What you'd have to do then is you have to define it. The reason why it worked is that you had to define it for a certain interval where it stays 1-to-1 in that interval. So so I couldn't do it for all real numbers, but yes, you technically you can do it for something that does have hills or peaks, but then you have to be selective and choose an interval where only that portion is 1-to-1 and doesn't have those peaks, those high-low points. So that just be mindful about that. Anyway, so let me just make a quick table down here. F inverse. So if I plug 0 in, cosine of 0 is 1 plus 3 times 0, so that's 1. So therefore 1, 0 is on the inverse graph. That's why that's 1 and that's 0. Then derivative is easy. Negative sine x plus 3. So f prime of 1, sorry, f prime of 0, because we're valuing it at 0 for the original, is 1 over the derivative of the inverse evaluated at 1, because 1's the input for the inverse. Well, f prime of 0 is easy. That's just going to be 3. So 3 equals 1 over the derivative inverse evaluated at 1. And that's what the question is asking for here. So that's going to be the reciprocal, so that's 1/3. So that's all we're doing. So I'm going to get some worksheets to do this over the weekend so you feel a little bit better about it. And if we need to spend more time on it next week, we can. And the more I think about it, I think I'll make an adjustment to your homework. Worksheet 14 is actually really long. I might want to save that for Tuesday next week. All you guys worksheet 15 instead. I was going to do worksheet 15 in class with you guys today. It's really short, but in the interest of time, I see it's 9:38, and I still need to do a lesson on 4.4. So we're just going to jump straight to that lesson right now. So let me go ahead and clear the screen. But it's good. We had to talk about this anyway, right? I mean, so let me stop the recording there.